All right, here's part C, the integral from 0 to 2 e to the minus x dx. Let's try to answer these questions. As always, this question number 1 and number 4 are the same, and number 2 and number 3 are the same questions essentially. Okay, we're investigating exact same things. So let's try to answer 1 and 4. The limits of integration are both finite. That's the first statement. Is that correct? Well, I look at the limits here. One is 0, the other one is 2. Interval of integration is just the interval 0, 2. We're safe. No infinity involved here, so yes and cross mark. Okay, the first one is yes. The answer for the last question is no. So is the integrand continuous on the interval of integration? So integrand is a function, which is a well-known function e to the minus x, and if you want to write that in the form of reciprocal, that's fine, 1 over e to the x. You can write it as a rational function. So the question is like, is there any x within the interval of integration, which is 0 and 2, that makes this function not continuous? Okay. First of all, e to the x is taking all positive values, and e to the x can never ever be 0, so we're not dividing by 0. And e to the x is defined for all x, so we're talking about a pretty nice function here, continuous. In fact, on minus infinity and infinity, but for this problem, it's particularly continuous on the interval of integration. Here we go. I'm going to put a check mark here. I'm going to put a cross mark here. So since the first two conditions are satisfied, first two items have check marks, then we go ahead and say like this integral is not improper. Okay, not improper. Okay, this is the conclusion here. All right, I think that's all. We are done with all parts of this question. Again, it's very important to pinpoint if before even we hit the road integrating the function, we would like to know if the integral is improper or not improper. So we have different recipes to attack these integrals. All right, thanks for watching. I'll see you in another video. Bye.